Hey everyone, welcome back to my channel EduVibe. In today's lesson, we are moving to the next topic of the atomic physics. We are continuing the antiparticles or subatomic particle topic in this too. So we are doing the particle zoo, which is a subatomic particle zoo. So we are doing the particles with some subatomic particles of their like a whole zoo. Like we have all particles, we have leptons and hadrons, two types. Hadrons are further be divided into mesons and bosons. That thing is just the introductory thing. You can't do like a very deep in this topic for now, but you can just the introduction of this topic, how the particles can be distributed in the antiparticles or the subatomic particles. So the particles, all the particles will follow into the two categories, which is the lepton and the hadron. The leptons is a come from the Greek word leptos, which means the thin or a small. Leptons are the smallest of the known particles. They are very smallest particles, whichever we know. You have to know this. By definition, leptons do not interact by means of strong nuclear force. They are not attracted by the strong nuclear force, so we have to keep it in mind this thing in mind. But they do interact with the weak nuclear force, gravitational force, or electromagnetic force if they have a charge. If they have a charge, so K can interact with the weak nuclear force, gravitational force, and the electromagnetic force. To date, only 6 leptons are there. This with their respective antiparticles has been discovered. They are the lepton, lepton neutrino, muon, muonoleutrino, truno, trunoleutrino. So they have all their respective antiparticles of the 6 known leptons for date till now. Leptons are considered the fundamental elementary particles. They are not made by the quarks. What are the quarks? We are discuss this topic more to the next lesson. So you have to know this. These are the fundamental particles, and they are the smallest known particles too. Next thing we have a hadrons. Hadrons are come from a Greek word which is the hadros, which means the thick. This means the thin. This means the thick. These parts do not interact via the strong force. They are affected by it. They are affected by it. They not attract by it. And they are then subdivided into the two categories, which is the protons and the mesons. So protons and the neutrons, which do not attract via the strong nuclear force, are considered the hadrons. Because of the protons and neutrons are not attracted with the strong nuclear force, they are called the hadrons. Because the hadrons are those things which are not interacted by the strong force. Then we have a mid-rating particles. In the 1970s, the research by the high energy particle accelerators determined that the strong nuclear force is mid-rated, which is carried by the zero mass particles such as gluons. The strong nuclear force is all the mid-rated particles can be attracted with that force, which all has a zero mass particles which don't have any mass are called the gluons. To more simplify, they are the used to be glue or hold cross together. So what are the cross? They hold the things together. In everything, in a proton or neutron, we have the cross which are like attached, attached by each other. We discuss this topic in the next lesson, which is very detailed, and we have this topic in the next lesson. It was later discovered that the weak nuclear force was mediated by the three mediating particles W positive, W negative, and Z0 bosons. Experiments using powerful accelerator detected by these three particles in 1983. So for now, you don't have to worry about this topic for more in detail. You have to just know by some like definitions, what they do, which type of force they have, which are their subparticles, subdivided things they have. Just that. We don't have to be too in detail at this topic. So in particle zoo, we have these four of the iteration thing. So they have the ranges, they have the relative strength of that, they have mutating particles which they involve in that, and we have a particle absorbed in that. This is a table for just the summary of that whole thing. Units for subatomic masses. It is very common in the particle gives you the mass in units of MeV per c square. So that's the unit, and that's the end thing we are discussed from our data sheet. Like the last thing that MeV c square, there are some conversions and they have some crossing, that which involves some particles and antiparticles. That section of the data sheet we used in the lessons. In this lesson, the next lesson. Let's do one example of this, that how can we actually converting the things between MeV square, C square things. So we have the question that determine the mass of the electron in MeV C squared. Give your answer into three significant digits. So we start with the calculating the energy. So the energy is equal to the MeC squared, the mass of the electron. So we have this multiplied by this, yeah, and you get your energy of about 8.199 into 10 raised to power minus 14 joules. You get this thing. You have to convert this to MeVC square. So you have to firstly convert it to EV. You can divide this by 1.629 raised to minus 19 joules. And then you have to convert this to MeV. You have to divide this by 10 raised to power 6 EV. Cancel out. When you calculate this, when you divide this whole thing, you get about 0.5124 is equal to MeV. Basically, you want a Me. So you know this is equal to the something like this, MEC square. So if you know this ME is equal to 0.512, this is basically equal to MEVC square. You have to just compare with like that, and you have to be take care of this thing, and you have to find the rest mass first compared to the electronegative in MEV to convert this. So that's the answer for in MEV scale of the electrons mass. So that process you have to follow. We discuss more question, practice question, diploma question when we're doing, but this is for now. That's just the introductory thing you have to know this. And there are some leptons, musons, and the hadrons. You have to just know the electron, the electron neutrino, and their symbols and their MEV conversion, and the proton and the neutron for now. You don't have to be memorize this whole table. Just note about the electron, electron neutrino, proton, and neutron. So that's all for this, and that is the end of this topic. So we have to just do the introductory part of this topic, and we can't do in some detail. There's some detail in that, but not for now. This for the higher studies. So that's all for this lesson. Let me swear to EduVibe, learn more not harder. Please like and subscribe to my channel. If you're having any questions, let me in the comment section. See you in the next lesson. Till let's meet with EduVibe.